All right. Well, thank you everyone for coming to the talk. This is Invoke DOSfuscation, looking at fin-style DOS level command obfuscation. And hopefully by the end of this talk, the syntax of this title slide will make just a little bit more sense. I'm also obsessed with coffee, which is why there's latte art in the front. A little bit about myself. I work with Mandiant FireEye out of the Washington, D.C. area. I started out doing incident response for a few years and have now transitioned to the advanced practices team doing applied research, basically writing detections, and my kind of sickness or obsession is looking at obfuscation techniques to break my own detections so that I can make them better before an attacker breaks them. And so some of the obfuscation projects I've worked on include Invoke Obfuscation, Cradle Crafter, Invoke DOSfuscation, which we'll talk about today, and then the Revoke Obfuscation detection framework. Brief disclaimer, nothing I talk about today points to any specific client of FireEye or Mandiant. Most of the stuff I'm talking about we've never seen in the wild before, but standard disclaimer. So, today, we're going to look at a quick overview of kind of the state of obfuscation and kind of from different angles, from red, blue, and then we're going to look at 3 case studies that really propelled me last year into starting this area of research. And then we're going to look at a couple of different layers of obfuscation, starting with something as simple as like binary name obfuscation, and then diving into character insertion obfuscation, and then adding all those things together to do full payload encoding, all using just native command.exe. And then we'll do a demo of Invoke DOSfuscation, and then we'll talk about detecting DOSfuscation. And there's a lot of content here, and so I've posted the slides online, and also there's a 36-page white paper with all of this research in it as well. So if you don't like the sound of my voice, you can leave now and then just read the white paper, and all the information is there with just a few less memes. So there's options. So first, the state of obfuscation. What does it look like today? Well, why obfuscate? From a red team perspective, obfuscation is great because it takes relatively little effort to evade rigid detections. And typically, they're targeting static detections to evade, but also some dynamic as well. And it increases the work for defenders. So we as defenders, even if we detect this payload, we still have to take extra time to decode it, to deobfuscate it, and see what is actually happening here. And there's obfuscation frameworks for almost any language you can think of, most of them open source. And even though I may be biased, I don't really see it slowing down anytime soon because it's just so effective. From a blue team perspective, there's actually been some significant strides in visibility and capabilities over the past several years. Things like Microsoft's anti-malware scan interface, or some things that have been around forever, like event tracing for Windows, that as the defensive community, we've kind of started to embrace more and use for better visibility. And then also some more signatureless kind of detection approaches using some different data science techniques. So there's been really cool strides in this industry for detection. But attackers, they just respond. And sometimes they respond by choosing a softer target in general, or they'll just straight up disable these defensive capabilities. Or they'll use languages that just don't provide this additional visibility. So this talk is kind of my response to all of this. And looking at command.exe obfuscation, as a defender, most of the detections that I see and conversations I have when it comes to command.exe is typically looking for a process named command.exe followed by certain arguments. Some additional detections could be looking for like parent-child process relationships. So explore spawning command.exe is a little less suspicious than windward spawning command.exe. There's tons of caveats to that statement. You could also look at command.exe as like the source of action. So command.exe modifying a registry key or doing something weird like that, or make a DNS request or something of that nature. But really when it comes down to it, what's the purpose of building an entire framework for generating obfuscated payloads for command.exe? So what got me into this was specifically 3 case studies of actual attackers that we investigated last year. And my manager, Nick Carr, and I, we co-authored this blog post the end of June about these 3 different techniques and these 3 different attackers. And so the groups we're going to talk about very briefly here are Fin8, a financial threat actor, APT32, also known as Ocean Lotus out of Vietnam, and then Fin7, also known as Carbonac. So the first example was in February of last year. Fin8, they really like to obfuscate their macros, and so this is a de-obfuscated version. And basically, they're using a lot of process-level environment variables to store their payloads in a lot of different places. And then they're setting a PowerShell command, which is just PowerShell dash, into one environment variable. Now, when you run PowerShell dash, it runs the PowerShell process, and it executes standard input as the command. They then have, at the very bottom here, they have the rest of the PowerShell command, which is pulling and reassembling the payload from additional process-level environment variables set by the parent Windward process. And so then the only child process you see out of windward.exe is the command at the very top. Command/c echo var1 pipe var2, which is echoing the PowerShell command into PowerShell dash. That's really cool. The second one, apt32. apt32 really embraces the latest trendy thing on Twitter. And so like when Casey Smith tweeted the regsurf32 squibbly-doo downloader, apt32, as did the rest of the world, it seems, jumped on it very, very quickly. So defenders also jumped on it very quickly and started to write detections, a lot of them based on /i:/HTTP. And so what apt32 did is they used the tried and true carrots. Now the caret is the escape character for command.exe, but if you escape a character that doesn't have any escapable meaning, then nothing happens. But now this caret is in the command line arguments or in the event logs, and so it can evade rigid detections that don't take this into account. Some people do take this into account. And so what apt32 did was they used the double quote instead. Now, I've mentioned the double quote a couple times over the past few years, and I'm amazed that more attackers don't use it, because it's a lot more resilient than the carrots, and a lot of defenders aren't looking for it, but it was cool to see them pull this out, and you can actually see they didn't put it in the entire command. They only put it very strategically in certain pieces that they knew detections were based off of. So I kind of call this tasteful obfuscation, as opposed to just throwing everything against the wall. Now, this last example single-handedly blew my mind and started me down this entire area of research. Fin7. Fin7 and apt32, they compete for first place in my heart for the coolest, most tasteful obfuscation, because they really obfuscate just certain pieces, and they do it really well. So this is actually extracted from a malicious link file that they dropped, and it actually has some JavaScript level obfuscation, as you can see, some string concatenation, and then for eval, they actually do an ASCII conversion and concatenate it. So that's kind of cool, and they're echoing that onto disk. But the two red boxes are what's really, really interesting. Now, when I saw this, it didn't make any sense, because as you can see, there's this WScript command, but it has this @ sign in it. Now, it would make sense if that was a caret, or if it was a double quote, but the @ sign, I couldn't get this command to run when I'd copied and pasted that and ran it. So what's going on here? Well, first, they're running command, and they're setting this WScript command into an environment variable called x. They then write out the JavaScript file, but then at the very end, they echo x into command. Because just like PowerShell, command can also receive from standard input. But then they put in these garbage delimiters, the @ sign. They put it in WScript and JScript, because perhaps some defenders were looking for these static strings and link files. But then, when they echo the x variable, they actually make space after the variable name, and they insert this syntax right here, which is really fascinating. So what this says, the colon after a variable name, but before the final %, it says, any string on the left side of the equal sign, find every instance of that string, and then replace it with a string on the right side of the equal sign. In this case, the string is just a single @ sign, and there's nothing on the right side, which means in memory, remove every @ sign from the variable x. How freaking cool is that? This is tasteful. This is delectable. This is just has so much finesse to it. And it got me wondering, this is native to command.exe? Is this a Win 10 thing, or has it been around forever? So you start Googling this stuff and realize this has been around for freaking forever. How cool is this? So this all happened very quickly. We found this payload on a Wednesday, blew my mind on a Thursday, wrote the blog post, put it out on a Friday. I went home, couldn't stop thinking about it. I spent that weekend writing this small POC, which I called out fin-coded command for fin-style encoding. And I released it on GitHub that Sunday, and as soon as I released it, I kind of sat back and thought, I wonder if there's more here. This was one really cool trick, and I wrote the POC to kind of generate some payloads to test my detections. But what else does Fin7 know that I don't about command.exe? What other hidden gems are there in this tool that we may get blindsided by in a couple weeks or a couple months, or maybe it's been used for years and we've just never seen it? So, implications of the kind of obfuscation we're about to talk about. I would argue that it affects both dynamic and static detections, and I'll kind of revisit this throughout. But basically, as a defender, a lot of times we'll think this is only going to affect static detections, like if you're running YAR rules against link files or extracting macros and looking at that. But you know, these characters will be removed when it actually runs on the command line. In that link file example, when WScript actually runs, that's true. There is not going to be an @ sign there, but there are things that we can do that remain. So we'll look at that. So basically, with this research and with the tool that I released with it, you'll be able to take any arbitrary input command for command.exe and start to apply layer upon layer of obfuscation and get something that looks like that. Let's see how it works. So hang on tight, there's a lot of information. We're going to move really fast, and we're going to visit all these building blocks. We're going to stack up to, at the end, be able to do some crazy payload encoding and obfuscation, and then we're going to talk about how in the world do you go about detecting this stuff. So let's start with obfuscation of binary names. Now, a lot of attackers know that that defenders will write detections that look like process name is command.exe and argument contains A, B, or C, or D and E, or blah, blah, blah. So an attacker could just simply copy command.exe to like benign.exe. That's one way of evading based on binary name, but that's not what I'm talking about. There's also a lot of kind of command.exe substitutes. So to break parent-child process relationships, if you have a rule looking for windward spawning command, well, an attacker could just use forfiles.exe and launch their code. Or they could use PCA Lua, or they could use run DLL, or MSHTA, or all these sorts of things, some more obvious than others. There's actually, there's kind of the term lolbins has been getting pretty popular recently, and so a lot of different people are tracking a lot of these native binaries that you should start looking for in addition to command.exe, but that's also not what I'm talking about. I'm looking at just purely the syntactical obfuscation of the string CMD and the string PowerShell as two specific binary names that we'd like to obfuscate. So one way we can do this is through environment variable encoding. Now, this is going to buy you good static detection, like in batch files, or like if you're looking at persistence in registry. But in most cases, this will resolve on the command line. So if you're looking at like sysmon EID1 or security EID 4688 for process execution events, for the most part, this will be deobfuscated. But what are we talking about? If we echo the environment variable program data, it's C program data or whatever drive you have mapped. So if I want to produce the string CMD to spawn command, I can just start to take substrings with this colon tilde, first index, comma, look ahead, and start to concatenate stuff this way. You can do the same thing with PowerShell as in the bottom. However, I wanted something that didn't resolve on the command line, because if you copy and paste this into the command prompt or run it through like WScript shell, when you actually see the command that runs, it's deobfuscated. However, there are ways that you can produce the string command in PowerShell without it actually being resolved in that initial command. So set, assoc, and ftype. These are just three internal commands that I came across as being useful to basically reassemble these strings. If you run set, it'll show you all the environment variable names plus the values. Assoc and ftype are actually related. So assoc is going to show the association between a file extension and the associated type, and then ftype will map that type to what binary should I run with what arguments to run this thing. But the reason I chose these is because each of them, if you run just the command, you'll get a lot of standard output, and they will contain the string CMD or PowerShell since it's where in that output. So let's stick with set since it's the most kind of straightforward example. So if I do set then find string PowerShell, I get two hits that come back. One is for the path variable, the other is for PS module path. Well, if I'm an attacker, then the path variable is likely going to be really different on a lot of different environments, so maybe I'll stick with PS module path. Maybe that's going to be more consistent for what I'm going for. So instead of doing find string PS module path, I can just do PSM, and that would also give me the result. And at the bottom, you'll see it's a code snippet from Invoke DOSfuscation that will basically randomly choose one of these substrings that will produce just the result for PS module path. So this is the exact text that we get, this bottom box here. So now, we actually see there's two places that the string PowerShell shows up. What we want to do is we want to basically lift both of those out of the text. And the way we can do that is look at what are the characters, the delimiters on either side of PowerShell. And in this case, it's the lowercase s and the backslash for both examples. So now if we delimit on the lowercase s and the backslash, it actually breaks up this value into 13 pieces. And we're interested in the 4th and the 11th piece, both of those being PowerShell. So now how can we actually do this on the command line using just command.exe? Well, the for loop in command.exe actually has a delims argument. So what we can do is we can run the for loop, and at the very end, we run our subcommand, which is our set find string PSM. It then takes those results, it applies the delimiters that you gave, and then you can say, I want the 4th token, and then it returns the string PowerShell. And we can either just echo that string, or we can just say, do the string that comes back, and it actually executes the string that comes back. So in this example, the for loop runs, it extracts a string PowerShell, and then invokes it or executes it, and in this case, drops us into a PowerShell prompt. So, in real quick, why this is important, if you're looking at process executions, you're going to see command.exe run, and nowhere in that argument is it going to be the string PowerShell. But you're obviously still going to see PowerShell run as a child process. So this isn't removing the process execution, but it's basically changing the dynamic indicator itself within the calling process. So that was binary name obfuscation, just kind of a quick look at that. Character insertion obfuscation. What does this look like? In most cases, this is more useful for evading static signatures, but there's plenty of dynamic use cases that I think aren't talked about quite a lot. The character is the most common one. The double quotes, as long as they're evenly balanced, that's really important, and we'll see why in a later example. This is what we saw APT32 using, amongst a lot of others, but it has some really nice features compared to the character, especially when you have a lot of child processes. Because of the escape character, if you have 10 child processes, you have to double up your escaping at every layer because it gets chopped in half every single time. With a double quote, there's no escaping of it, so it'll persist all the way down no matter how many child processes you have. Encapsulating parentheses, the first time I saw this being used, and I don't think it was being used for obfuscation purposes, it was in investigating some newscaster activity, but for any command, and in some subcommands, you can actually wrap with as many layers as you want of evenly balanced parentheses. And this could be important if as a defender you're writing detections looking for like concatenated commands using like the single or double ampersand or the double vertical pipes, and then looking for white space followed by netstat or some other command. Well, now you can actually put a lot of parentheses in between there. So if you're writing those kinds of rules, you need to take that into account as well. Leading and trailing special characters. This may be a little hard to see on this slide, but after looking at the parentheses, that got me wondering, what additional characters exist that you can still put in a command that will function properly? And so I wrote a little fuzzer script to go through and start just injecting characters and running the command and seeing if the expected output came out. And so with that tool, I basically came across the comma and the semicolon. Now you can put a comma or semicolon almost anywhere where white space exists. And basically, it's when white space is acting as a delimiter, the comma and semicolon can also be used as delimiter characters. Now, this will get really crazy really fast when we start to add all these pieces together. Standard input argument hiding. We looked at this in the previous example. You can echo content into command. Non-existent environment variables. This is only good for static, like for batch files. It doesn't work on the command line. But and this actually was from a blog post that someone wrote several years ago, so I didn't discover this. But basically, you can put non-existent environment variables all throughout the command, and the batch file will essentially resolve it to nothing, and then the command is deobfuscated when it runs. But again, that's only for static batch file stuff. It doesn't work on the command line. Setting custom environment variables. We've seen this used primarily in like link files, where you can basically chop up, in this case, they're wanting to chop up the string PowerShell, and so they set the character P into a variable, and then they call that variable in the same session. And we'll look at some of the components of this command that let you do that, all within the same process, which is pretty interesting, and actually a core building block of what we'll talk about over the next few slides. And then, as we discussed earlier, you can use existing environment variables and just start to concatenate substrings of existing values. So when I released the outfin-coded command POC, one of the options was, do you want your final command to be run by command.exe or PowerShell.exe? And so I also included a couple just kind of like pre-built obfuscated syntaxes for doing command or PowerShell. And these are the two tweets I put out, just kind of showing you can run command or PowerShell with these concatenated substrings. And someone replied on Twitter with this, an entire command of nothing but concatenated substrings. Funny enough, some people actually ran this and then complained to me that I infected their system. And it's like, I didn't even write this. What are you doing running code on the internet? So that was interesting. So once, in the research process, once I started to find some of these techniques, as soon as I found another technique, I documented it, but then I built the detection for it and said, have we ever seen this before? I started to search our internal repositories as well as doing retro hunts on VirusTotal and just scouring web forums and seeing what I can find. And for the substring concatenation, it's actually been around for a long time. This is an example of Devourer malware back from 2012, and I'm sure it's a lot older. The technique goes back a lot further than that, but this one just happened to be re-uploaded to VT not too long ago, where they're basically using environment variable concatenation to do batch file obfuscation. This next one is really cool. This one actually is used a lot, and even by a couple interesting Chinese APT groups using a variation of this tool. JS Batch Obfuscator was written 2.5 years ago. It's up on GitHub. It's like less than 50 lines of code, but it's a really cool tool just for obfuscating batch files. But this uses an approach of, instead of using existing environment variables, the batch file starts with setting a random name environment variable and setting it with a full alphabet, or later custom versions just do only the characters needed in the command. And then the rest of the command is just concatenating the characters one by one from that random environment variable. And there's the decoded version there of this particular payload. And this last one, I won't go into too much detail, but if you check out the white paper, this was a really interesting fish and really interesting payload called a batch encryption, just one piece of a larger kind of obfuscation component. But this actually combines both known environment variables and unknown environment variables by setting them into a variable called a single quote. That's just what they named it. And then the rest of the command goes through there. But again, a lot more details in the white paper. But all this to say that it's cool when something you didn't know existed, all of a sudden you realize, crap, this has been around for a while, and I'm just now seeing this with my own eyes based on this research. I think I'm onto something, but I wonder if there's more things there that I've never seen before. So let's keep going into advanced payload obfuscation. Now, I use this example here, and if you're a defender, the first half of this command might look familiar. Comspec bc star bmin. This is used all over the place by Metasploit and several other tools. And if you see this in the registry in a run key, if you see this in security 7045 service creation, then you have some issues. %comspec% should send up huge red flags to any defender, which is why I wanted to use this in this example. And the rest of the command is just doing a netstat find string, something simple that we can use to obfuscate. And you can see that we run the command here. It's looking for listening results when you run netstat. Here's just a quick breakdown of the components of this command. Whenever you look at a command, either as an attacker or a defender, it's interesting to ask the question, are all these things necessary? Are they necessary in this order? Can I change the syntax of any of this and still get it to run how I want it to? So starting with ComSpec, there's two ways we can go about obfuscating this. One is using environment variable substring syntax. So if you echo ComSpec, it's 27 characters and it's the full path to command.exe. So using substring syntax, we could say, hey, start from the 0th character and go out 27 characters and let's use that value. And it's going to be the full value. You don't have to specify how many characters to go out. If you don't, it will go out to the end. You can also do reverse indexes, so start from the end and go back 27 characters to start, and then go forward the rest of the way. And there's nothing saying you have to use the exact length. Instead of 27, we could use 1337 or anything that's greater than the value of the variable. So these will all still successfully produce a string command.exe with the full path. You can also use environment variable substitution. So just like we saw Fin7 substituting the @ sign with nothing to remove it, we could basically say substitute forward slashes for backslashes, or substitute something that will never exist with something else that we never want to see because it doesn't matter. All we're doing is breaking detections that are looking for %comspec%. So let's just choose 2 of these and keep going. We can randomize the case of the variables. If anyone's doing case-sensitive detections on this, looking for anomalies is actually a good way to detect some of this stuff. But just in case, As defenders, we should know it's possible to do this. You can also add white space before each of the two indexes. And actually, the bottom command, technically this changes how it functions, but it doesn't matter because we wanted the original value anyways. And then we can also explicitly sign integers. Now, I don't know about you, but I've never really looked at a 0 and thought it needed to be positive or negative, because that doesn't make any sense. But it's actually technically possible on the command line, so maybe that's an interesting thing to look for. Do I ever expect to see that? So let's go with the second option and put it in the command. Now, a really important point here is that context is crucial. I do get a lot of complaints for this because people complain that my tool doesn't work if you drop it into this payload or that payload. And I remind them, it's like, I'm a defender, right? Like, I didn't write this to like pump out all these crazy things. I wrote it for defenders to be able to look at all these options and to write detections for it. And if you're an attacker and you're too lazy to go and fiddle with this, then you probably shouldn't be using this. So the context is important. If you drop this into command.exe, it will run. If you are in a command like context like wscript shell, this will also work. But if you drop this command into like a service or a registry run key or something like that, it won't work. Because this substring syntax is a command.exe thing. The reason %comspec% works is it's literally like a find and replace the operating system does in the run key or service to say, oh, this is a known environment variable, let me lift that and replace it with the value. But it doesn't know how to interpret the substring syntax. Now, this only matters for the first part of the command. If the first part of our command is just cmd.exe, and then later we use a substring syntax, that's fine because the command engine is interpreting that. But it's just something to be mindful of. So for the rest of the command, we can apply a lot of the techniques we talked about in the last section. So we can randomize the case of all this. We can actually remove a lot of white space. So I don't know if you've seen many commands that don't have any white space between the arguments, but BC, start, bmin, all that stuff, white space isn't needed. And a fascinating thing here is that you'll see there's 0 white space between that first argument /b and the command.exe. But when you look at the dynamic execution, the operating system adds a white space in there. So if you write a detection that works for this command, if it's in registry, it's actually going to look different when you actually see it running on the command line or when you see it in process execution logs. So now, wow, we can actually have to write slightly different detections or more robust detections, whether we're applying it to dynamic data or static data. It's getting tricky. So we can remove that white space. Netstat ANO, we can just move that around because it still runs just fine. We can also add a lot of white space. Remember those commas and semicolons we talked about? Anywhere where you have white space used as a delimiter, you can use commas and semicolons. But you can put as many as you want, even if you don't need a delimiter there, and it actually doesn't affect the command. We can add tons of caret characters, and we can escape at multiple levels depending on the functionality we want to exist, depending on how many child processes we have. And if we run this, look, the process execution is like bottom up. We'll see that we get this interesting intermediate command that's highlighted blue. So as a defender, and we'll talk more about this in the detection section, if you see command.exe run as command.exe 2 spaces /s space /d space /c no space double quote 1 space and then something, this is actually an artifact of the operating system in a couple scenarios, like subcommand execution or when you're piping content into a new binary. It'll actually spawn this intermediate process, and there's really interesting and valuable detection opportunities when you see this syntax right here. That we'll talk about towards the end of this talk. But the important thing here is that the carets in that intermediate process, they're all chopped in half, right? Because the escaping diminishes by half every single layer. And once you get to the fine string and the netstat, there's no obfuscation left. These characters are all gone. You're just left with the spacing and the casing. So if the comma and semicolon and caret don't persist, is there a character that does persist into that final child process? The answer is yes, and the double quote is making a shining entry in here. And what's awesome about this is that you don't have to worry about different layers of escaping. You put it in the first command, it persists all the way down into every child process. So, when in writing the tool, this became insanely complicated to basically keep all these things in place. And in doing PowerShell obfuscation, it was great because you have access to the language tokenizer to parse the command you're looking at, to know this is a string, this is a command, this is an argument. You also could have access to the abstract syntax tree to do all this kind of stuff. Command.exe doesn't have any of that crap. So it gets really tough to basically piece all this stuff together and know kind of where you're at and how many layers of escaping you need at each part. So this is what I call the world's tiniest violin slide. The defenders are giving me no sympathy right now, but basically it was a really interesting challenge to go through without these tools that I have with PowerShell. And it was just a much more rigid kind of framework to work within from an obfuscation perspective. So some defenders may look at me and say, okay, dude, well, I don't care about your dynamic stuff because I'm already looking for carets. I'm looking for commas and semicolons. Plus half those examples, they were removed anyways. And okay, maybe I didn't know about the double quotes, but I'll start looking for that. Like, this doesn't really faze me. Like, why should I worry about this obfuscation stuff as much as you're talking about? Well, I would argue that obfuscation is a great way to give zero crap about an attacker's intent. Because if I can detect obfuscation, I don't have to think, I wonder if this netstat command is malicious or not. It's like, whoa, obfuscation, someone doesn't want me to read this. I'm super interested now. So I would argue it's important to detect obfuscation in and of itself. And as another reason why, there's a lot of things that an attacker can do that if they have a command.exe argument that's obfuscated, that never spawns a child process. A lot of recon. An attacker could list all the files. They could type and actually essentially cat the files. Maybe they would add an entry to your host file and sinkhole your cloud-based security product. Wouldn't you want to know about that? If this command never showed up in plain text but was insanely obfuscated, I would want to know about that. So, with this being said, the last part of this research was, is there a way that I can obfuscate any arbitrary command without using any of these characters that we just talked about? Without having to rely on these special characters that defenders could, I don't want to say easily implement, but could start looking for. Is there a way a sneaky attacker could get around? So the first of the 4 techniques we'll look at is concatenation. So netstat tac ANO, we'll use that example again. And fun fact, you can also use the / instead of a dash for that argument right there. This actually has really interesting implications. So as a bonus, think about, as a defender or an attacker, what are the detections that are based on arguments for commands? Okay, if you're looking for wscript / no logo, you can actually change that to a dash, and it works. For PowerShell, not nani encoded, instead of dashes, you can use slashes or interchange them. For regserve, detections looking for /i:/HTTP, you could use a dash and get right around that. And also, if you look at the URL, instead of // you could use backward slashes. So how many people are looking at different slashes in URLs? And maybe they just do HTTP : and that's enough. And some languages even let you interchange forward and backward slashes after URLs. So again, when we're doing content regexes or things like that, like, are we taking these things into account? So anytime now when I'm writing a detection, if I see a slash or a dash, you better believe I'm interchanging those and playing around and poking at it to see, is it possible with this binary to do this thing? So back to concatenation. What we're going to do is we're going to set our netstat command into an environment variable, and then let's just echo the variable. In this case, we're calling it com, and let's just make sure that our payload was set successfully. Now, if we just echo the variable, it actually doesn't give us the value. It just gives us the variable name. That's because the variable isn't expanded in the current session. So 2 ways we can do that. The very bottom example is, well, we can just spawn a child process, and then at that point, the variable that we set will be expanded. But I don't really want to spawn an extra process. That's a little too noisy. So what you can actually do, one example, is using the internal call command, which says expand the variable. I want the value of it. And as you can see in the middle command, we get the value. So if we replace that into our command, then if we run it, then it actually successfully expands and executes the value we just set. Okay, perfect. Well, instead of having 1 variable, what if we chop up our entire command into 3 variables, com1 through 3, and then we call the concatenation of com1, 2, and 3. Now, an interesting thing happens here. It runs successfully, but this is actually some screenshots from sysmon EID1, and if you'll notice, the parent command line is perfectly fine, but the image process command line actually has 2% for every single %. And this is incorrect. I released a blog post several weeks ago on this. This is actually a parsing bug in sysmon where it doesn't properly escape the %. And there's really interesting bugs that can come out if you're using Event Viewer to look at event logs or PowerShell's get-when event. It actually improperly handles this improperly escaped %. There's a lot of implications there, but essentially you can, if you have detections that are relying on it being a single %, then system1 is going to give you double percents. So I don't mean to harp on that too long, but basically it's important to test your data as well as the tools you use to analyze the data, and try a couple different tools and make sure that it lines up. Actually, I reported this bug twice to Microsoft over a year and a half, and I hope to see it changed maybe after a year and a half. That'd be nice. So anyways, what we can do is we can also reorder our substrings when we set the initial command, as long as we reassemble them back in the right order. And then finally, we could just set all of them into a final command, and then just have one command to play with for our final execution options. So netstat, chopped up into little pieces, reassembled into a variable called final. We can just call final, and it runs our command. Now, at this point, there are kind of 5 options in the tools for how you can run the final payload. One is what we have right here. If at all possible, we don't want to spawn a child process, so let's just run the call command. Now, there are fringe cases in which you have to, well, in which I've not found a good way to not use call. Like if you have vertical pipes or things like that, when it expands, it actually interprets it, so it gets kind of weird. In that case, you want a child process. What's your options 2 and 3? You can basically just say command C, run the final variable, or you can echo the final variable into the command, the second process. And options 4 and 5 are the same, except they have to do with PowerShell. So I also built into the tool the ability to handle PowerShell layer escaping inside of DOS layer escaping to handle that, and that was just madness. But it's there and it works, and this is kind of what that syntax will look like. And so with this basic command, we've obfuscated the netstat command, and dynamically it looks, you'll still see netstat run as a child process, but our original command here is chopped up, and we didn't use any carets, commas, semicolons, anything like that. But if we're evil and we want to, we totally can, and the tool will help you do that. So you can randomize the case, you can add, remove white space, you can also add commas and semicolons, you can add carets of different layers, you can also add the nested parentheses, and it runs just fine. Now, when it runs, in this case, it still just runs the netstat command. But what you can do is, as input, you can add your own obfuscation to netstat, like carets or double quotes, and the tool will properly handle all of your special characters at input, and it will handle all the layers of escaping necessary to still produce the proper command as output. So if as input you have netstat that has double quote inside of it, the tool will properly handle that throughout all the layers. But now, there's a huge difference here between 2 double quotes side by side and double quotes that aren't adjacent. Now, it's important that you have evenly paired double quotes, but the reason this is a problem, if we try to do this in the command, it's actually not going to work, because there's no way to escape double quotes in the command.exe's arguments. And the fact that these double quotes remain is just kind of this weird concept of like, almost the arguments are just kind of being like concatenated together, but the quotes still stay. So this was a problem for me. How do I, if I have evenly balanced double quotes that aren't adjacent, how can I make this work? Because there are going to be situations in which someone wants to input a command that has double quotes that aren't adjacent. So I kind of, after a lot of head banging, came up with a 4-step solution for this that's all handled in the tool. If you ever have something that has to be double quoted like this, it handles all this for you. So basically, anywhere where I want a non-adjacent double quote, I double it up. I make 2 double quotes. The next step is I set an environment variable, in this case let's call it quotes, and I set it with the value quote quote, because I have to have an even number of quotes throughout my command. Next, our final variable, I'm going to use this substring syntax, or this character substitution, and I'm going to say, hey, find every instance of quote quote, and I want to replace it with 1 quote. But I can't just put 1 quote there, because then I'm going to have unbalanced double quotes. What to do? But what I can do is inside of this, I can call the quotes variable and say, I just want 1 of you. Now in the command, we still have even double quotes, but in memory, I want just 1. Unfortunately, this doesn't work. This doesn't work because of those percent signs, because we have our final variable, that's percent and the stuff in between, but then inside of that, we're trying to put more percents. So it's like, all right, well, how can I get something in memory? Maybe, is there another way that I can extract the value of an environment variable without using percents? Fun fact, if you're on Vista or later, you can use a /Vista flag. Now, hear me out. When you use the /Vista flag, instead of percents for a variable, you can actually use exclamation points. So now, our quotes variable is resolved in memory inside of the percents. There's no conflict there. And this command freaking works. Double quotes, evenly paired, not adjacent. Awesome. Now I have to admit, this is a little bit of a troll. This does work, but there is no such thing as the Vista flag. If you look at command's help menu, you will see though /v:/on, which is enabling delayed environment variable expansion. But when I see that, I can't just look for v:/on. I have to poke at it a little bit. What I found is that you can use any substring of v:/on, as long as it's not v:/off and a couple other interesting fringe cases. But then you can do /v almost anything else, and it still works. Yikes. All right, well, that just got interesting. I'll come back to that in a second. We'll have some more fun with that. But also, environment variable names, yeah, com, final, quotes, this is dumb. It's just to make the example easier. An attacker or a tool could just make all those special characters for environment variable names. You could also start with a non-white space character, then have differing lengths of white space to be your variable names, and it can just get crazier and crazier from there. So, dude, what the crap? You call yourself a defender? Why are you doing this stuff? Well, I started with concatenation because we'd actually already seen little baby steps of this in the wild. Most of them coming from malicious link files, but attackers never seem to move past obfuscating just a small piece of the command. And in almost every single case we saw before this research, it was just obfuscating the string PowerShell. As in this scenario, this one's similar. The yellow spots are just like random crap in random variables that aren't even called. They're just trying to break it up. I threw some carrots in that one. And then this one as well. And as you can see, this one uses that /v at the beginning as well. So now you're starting to notice this /v thing. Okay, that means they don't have to spawn a child process. And oh yeah, they're using exclamation points instead of percents for their variables. Cool, that's neat. So that was technique 1 of 4, concatenation. And again, the part of that we've seen in the wild is just these like little link files. The next 3 we're going to talk about, we've not seen in the wild as of the time that this research was finished. And when I say that, what I mean is that for the past 9 months, or at this point, I guess 10 months, my life has been looking at these techniques and then searching for them across all of our internal information at FireEye, VirusTotal, and all these different places, and then running all these detections across millions and millions of endpoints and on the network to look for these techniques, and I've come up completely empty. So I feel like it's going to be really interesting when we see this stuff in the wild, but it's all things that we've not seen before this research. So, the for loop. For loop is freaking cool. It does some fun stuff for us with command.exe. So I dubbed this for coding, for loop encoding. And again, if you go back to the command's help menu, I love this verbiage here. It says, when you use the variable expansion, you can use exclamation points instead of percents, which is quite a different thing when inside of a for loop. That is an understatement. It gets crazy different in a for loop. So what do I mean? Well, let's start with our netstat command again. Let's make sure we have that v in there for variable expansion. And again, it could be any of these options, but we'll just stick with v. Another fun thing. Remember I said you want to look at your arguments to see, do I have to have this? Or what does this thing mean? How many people think the /c is necessary for command to run non-interactive commands? There actually are other options like k, stuff like that. But C is, again, just saying, hey, everything else after this is an argument. Well, if you scroll down on the help menu, you'll find that for compatibility reasons, /r is the same as /c. All right, well, that got weird because I know attackers like to rename binaries, so I don't want to write my detections based off of command.exe. So /c seemed like a good place to kind of anchor off of, but now, instead of /c, we could just replace that with a /r and it still works. Okay, well, I'm gonna make sure I look for both of those now. That's kind of weird. The way I remember this is CRV, C and R for the command, and V for variable expansion. Another amazing thing is this is what I like to call a huge troll opportunity, because all that space before the /c or /r, you can put anything you want. This command works. It doesn't show that GIF, but you can put almost anything you want, and it's not interpreted. So an attacker, could be nice and send you funny messages and stuff in the command. Some do. You could also do this. So if an analyst is looking at this, what do you think is going to happen when you run this command? You'll see the path variable, right? Anything look weird about this? What about all this white space before that netstat command down there? \C has no meaning. It's /C that we're looking for, or /R. So when you run this, netstat's going to run. So if you're an analyst and you see that horizontal scroll bar be really tiny, you might want to slide over and see what's over there. Or just enable wrapping lines or something. I don't know. Gosh, man, this is getting rough. All right, anyways, for loop encoding, how do we do this? Well, we take our command, we take all the unique characters for that command, and we set it in a variable, let's call it unique. We then have a for loop, and inside of that, we're going to put the indexes of each character of our command. So for netstat, 0, 1, 2, etc., that's our command. And then we're going to end with one more value that in this case is just not going to be one of the normal values, and this is kind of our bookend delimiter. Then for each one of those loops, we are going to set and append onto this new variable called final the index from the for loop of the unique variable. And so loop by loop, we're going to reassemble our command in memory, and then each time we're going to check and say, hey, are you the bookend delimiter? And then if you are, all right, let's actually execute whatever's in the final variable. And this is what it looks like here. And so in standard output, you have every iteration of the for loop, but none of it actually hits the command line logging, which is pretty nice. And then the final command runs from memory. Pretty sweet. If you want to increase the obfuscation, you can add a bunch of garbage characters into this unique variable, or reorder it and all that stuff, and just update your indexes, and it works just fine there. And then invoke DOSfuscation will wrap all the building blocks we talked about. So randomize casing, remove white space, add it, commas and semicolons, carets, parentheses, and then also explicit signing if we want to. Whew, crap. All right. So that just happened. Well, there's also another troll opportunity here that I built into the tool. For that unique variable, you can put any message you want, and then any character still missing in your input payload, it'll just add those to the end. So again, attackers can have fun. They can be nice sometimes, so you can put whatever you want to in there and give some deeper people like me some laughs. All right. Concatenation was number one. We just talked about for loop encoding or for coding. Reversal was almost the same, except it uses this /L. So instead of having to specify every single index, we just say start, end, and the increment, decrement in between. And then we just set our command in reverse and iterate through, and that becomes our payload. We can add additional characters in there and adjust the incrementer, decrementer, and start and end payload, etc. I'm going to skip that. It's in the paper. For the final variables, we're using this substring syntax. And the reason is because in the for loop, we don't have any value set for the final variable. So we have to basically remove the name of the final variable, which we can do with a negative index. We can also do with a positive index of the length of the variable. And these are all random options on the tool. It'll take care of this for you. Or you can do a string replace on the name of the index and exclamation point. And that asterisk, when you have a string replace starting with an asterisk, it says find the first match of this and replace that and all the characters leading up to it with whatever's on the right side of the equal sign. The very last one is fin coding. In this case, we're going to start swapping out characters. So take every T in your command. We're going to swap it with a Z. And then in memory, we're going to do a string substitution for Z back to T that does that swap in memory. We'll add another layer, and then we'll call the sub1 that we just did. We'll add another layer and replace A's with 7s. Later, replace it back to A's in memory, and then call sub2, add another layer, etc. And at the very bottom, this is an example of the crappy POC I released a year ago. I didn't know about the variable expansion stuff. So for every single substitution, I spawned the new child process. So that tree was like 1, 2, 3, 4, 5, 6, 7. Oh, it was horrible. And also because of that, I had to spawn multiple processes. I had to do different layers of escaping for the ands, for the ampersand. So 1 layer, 2 layer, 3 layer. It got really ugly really fast. So that was a lot to go through. Let's got a quick demo. If you know me, I like to do ASCII art. That's the extent of my artistic capabilities, I think. So anyways, this is just some Invoke DOSfuscation ASCII art, adding some layers of obfuscation, some fun color-coded stuff. The look and feel it's the same kind of wrapper user interface as the other obfuscation frameworks that I've worked on. You can look at tutorials, help menus, all that stuff. It'll kind of show you what to do. Yellow takes you to a new menu. Green actually applies a thing. So in this case, we have 3 options here, binary, encoding, and payload. Binary is simply going to produce syntax that is the string CMD or PowerShell. That's it. So you can go here and play around with it and just copy and paste that into some other command or payload that you have. And then in this case, let's copy to the clipboard, paste it into command to show that it still works. Still works. Sweet. Let's go back. Let's say we actually want to input a command. and then apply that environment variable substring concatenation. We can do that with the encoding options. So in this case, we're going to set a command. We'll just do ping 8888. We can go show at any time and say, here's our command, here's all the options we've applied. We'll go through level 1, and you can see it just chooses maybe 1 or 2 characters and applies substring, or you can do the whole thing, copy the clipboard, throw it in, and we can see that it actually runs it just fine. But the real meat of the project is in the 3rd section, which is payload, which again, any arbitrary command or PowerShell input command, you can add all these crazy things. So in this case, I actually want to run a PowerShell command from command. So I'm going to set my command to be this right host PowerShell command, and then I'm going to say set final binary to be PowerShell. So I'm handling PowerShell escaping inside of command.exe escaping. Let's then go to payload. We'll do concatenation, and there's kind of 3 profiles, 1, 2, or 3. And 1 is not going to have any of the crazy special characters. It's just going to do kind of the least common work, or the least amount of work to get the job done. But 3 is more fun, let's be real, because you're going to get something that looks like that. And it's random every single time, and you can copy and paste that and see the command still works. And kind of as a, fast forward just a little bit, kind of as a finale, what I decided to do was I created a PowerShell command and a bit.ly link. I ran it through all my other tools. I created a download cradle through Invoke Cradle Crafter. I then took that output, ran it through Invoke Obfuscation for token layer obfuscation. I then ran that through Invoke DOSfuscation for this for loop stuff. And then when you paste that in, I'm actually going to fast forward because my VM was hating life when I did this. like really not happy. When you do this non-interactively, it happens just like that, so don't be fooled, but there you go, the command works. So, red teamer's like, cool, defender's like, I'm gonna see you afterwards. So, yeah, the disclaimer is always, please don't use this tool for evil, and if you're Fin 7, 8, or APT32 and define evil differently than I do, just don't use it at all. I know you will, but whatever. It's up on GitHub. So detecting DOSfuscation. Again, tons of information I put in the white paper because the whole reason I do this research is to detect stuff I've never seen before, to find out it's possible, and then to share with the community so you don't have to waste as many hours and nights and weekends as I did on this. So again, a lot of details in the white paper. But basically, we can start to look for really long argument lengths. We can look for high frequency of these special characters. None of this is easy, by the way. Like, these bullet points are freaking hard. There's a reason it took me months and months and months of doing this to try to get to a point where I felt okay with releasing it and sharing it. But one really valuable one is looking for obfuscation of known internal commands, because when you start to break all this down, there's several building blocks necessary to make all this stuff happen. And so when you identify those building blocks, looking for the obfuscation of those is really important. SDC, there's more information in the paper about that. Again, artifacts of subcommands and standard input. I suffer from FOMO, but for me, it's fear of missing obfuscation. It's very real. It's very real. So when I'm doing this research, I can't keep all this stuff in my head. So I write a tool that does it for me. And then I generate thousands of examples with that tool and let it test my detections that I write and see, hey, out of these 1,000 examples, you missed these 3. And then I look at those 3 and say, okay, what about these evaded my detections? And then I go and add that in. So for this project, I released the full test harness, the exact code that I used to write every detection from this research, and I released it with the project. And I also released 4,000 obfuscated examples as text files, as well as security EID 4688 events, as well as Sysmon EID 1 events. So if you don't want to run my code, you don't have to, but I have tons of sample data that you can use to test it. And the last thing I'll say about this is that when you run the tool, like in the demo, you only get 3 profiles of like low, medium, or high. And there's a lot of randomization in there, but you don't get the full gamut of obfuscation. With the test harness, you get the full gamut. Every single time you run it, there's over 20 different switches it flips to test, to basically change the percentages of all these special characters and stuff like that. And basically what you do is you start to add in your regexes and your searches for this obfuscation, and it'll go through and say, hey, here's how many you missed, here's the ones that match, here's the ones you want to look at again. So key takeaways, attackers love to obfuscate because it's still effective. Command has crazy obfuscation capabilities when you stack all these building blocks together. And as defenders, we kind of have to match the attacker's level of creativity. And again, I know it's not easy, but like we have to start thinking differently about some of these things, even if we've never seen them before. And I really hope that this research will help people do that. I just want to give a huge thanks to the advanced practices team, mainly Nick Carr, Matt Dunwoody, been with. I get to work with some awesome people who really make hunting threat actors like insanely fun and really support this kind of research, which is awesome. And definitely my wife, because she supports like insane hours with doing this stuff. This is about 9 months of research, over 1,000 hours when it's all said and done. and just a lot of coffee also in that process. So with that, here's my Twitter handle, my blog, the code is on my GitHub, the white paper's there. I'll be around the rest of tonight. I'm really excited to talk. I'm very sure I'm at my time. So please come and say hello and ask questions afterwards. And just thank you so much for your time. It's really an honor to be here. Thanks.